Welcome to this video. Today, in this video, we will discuss distance formula between 2 points. If you are told that your house is located 15 kilometers east and 20 kilometers north from the temple, then can you find the distance from the temple to the house? First of all, we represent it graphically, which is what we see in this picture, where point O is represented as temple and point B as the house. Let the point O be located at the origin point 0, 0. If point O is joined to the point B, then a right-angled triangle is obtained here. Here, the line OB tells the distance between the temple and the house. Can you tell something by looking at this right-angled triangle? Good. In the first chapter, we learned that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the remaining two sides, which is the Pythagoras theorem. Here, by using the Pythagoras theorem in this graph, we obtain the distance between the origin point O to B as 25. So the distance between the temple and the house will be 25 kilometers. Now, if your school is located 20 kilometers east and 30 kilometers north of the house, then can you find the distance between the house and the school? Let's solve this together. As we have seen from the graph, the coordinates of the point B are 15 from the x-axis and 20 from the y-axis. Then, let's represent the coordinates of the point B, that is 15, as x1 and 20 as y1. Similarly, school has the coordinates of the point D will be obtained as 35 from the x-axis and 50 from the y-axis. Then, represent the coordinates of the point D, that is 35 as x2 and 50 as y2. Since now we have to find the distance between these 2 points, that is point B and point D, we draw the perpendiculars BP and DQ from the points B and D respectively on the x-axis. And also, let's draw another perpendicular from the point B on DQ, which intersects DQ at the point R. Can you tell the coordinates of the points P and Q? Good. The coordinates of point P and Q are 15, 0 and 35, 0 respectively. Here, OP equals x1, OQ equals x2, so PQ equals x2 minus x1, which is equal to BR. And looking carefully at the graph, QD equals y2 and QR equals y1, which is equal to PB. Hence, RD will be equal to y2 minus y1. So in triangle BRD, using the Pythagoras theorem, from equation 3, that is, the distance between the point B, x1, y1 and point D, x2, y2, BD equals square root of the square of x2 minus x1 plus the square of y2 minus y1, which is called the distance formula. Since distance is always non-negative, here we will take the positive square root. Now in equation 3, put the values of x1, y1 and x2, y2, from which the distance between the points B and D is obtained as 10 square root 13. So, the distance between the house and the school is 10 square root 13 kilometers. Today, in this video, we studied the distance formula between 2 points. In the next video, we will practice some examples based on this. Welcome to this video. In our previous video, we learned the formula for finding the distance between 2 points. Today, we will see some interesting examples based on this. Check if the point A 8, 3, point B 0, 9 and point C 14, 11 are the vertices of an isosceles right-angled triangle. Can you tell us what we need to do? Good. For this, we use the distance formula. Let's find the distances between AB, BC and CA. Suppose the coordinates of point A, that is x1, is equal to 8 and y1 is equal to 3. And the coordinates of point B are equal to x2, equal to 0 and y2 equal to 9. According to the distance formula, we get the value of AB as 10. Similarly, the coordinates of the point C are x3 equal to 14 and y3 equal to 11. According to the distance formula, we get the measure of BC as 10 root of 2. Similarly, can you find the measure of CA by using the distance formula? Perfect. The measure of CA is 10. If you look carefully, we get the values AB and CA as equal, which satisfies the condition of an isosceles triangle. But we have to check for an isosceles right-angled triangle. Can you tell how we can check if it is an isosceles right-angled triangle? Good. For this, we will use the Pythagoras theorem. First of all, can you tell from which of these three sides AB, BC, CA will be the hypotenuse? From the measure of these three sides, we observe that the hypotenuse of this triangle will be BC because the length of BC is the largest. Now, by placing the values of these three in the Pythagoras theorem, let's verify if it's a right-angled triangle. If we sum the squares of AB and CA, we get 200, which is equal to the square of BC. So, we can say that it is an isosceles right-angled triangle. Let's look at another example. Find the coordinates of the points on the x-axis, which is 5 units away from the point 6, -3. Pause the video to solve and then check your answer. Can you tell what we have to do first? Right answer. For this, we will take the help of distance formula. Let us first assume that the coordinates of the point on the x-axis are x, 0. Here, we are given another coordinate point 6, -3, whose first point 6 is represented by x1 and -3 by y1. Similarly, the point on x-axis is represented by x2 and 0 by y2. Note that the distance value has already been given here. Putting all the values in the distance formula, an equation is found. Squaring both the sides of this equation, we get a quadratic equation. You must remember that we have already studied many methods of solving quadratic equations. Here, we solve the quadratic equation by the method of splitting the middle term, from which we get two values of x, that is, x is equal to 2 and 10. X is equal to 2 and 10. So, we can say that there are two coordinates 2, 0 and 10, 0 located on the x-axis. In this video, we saw some interesting examples based on the distance formula between 2 points. In the next video, we will see what are the common mistakes one can commit while solving these types of questions. Welcome to this video. In the previous video, we saw examples based on the distance formula between 2 points. Today, we will see what are the common mistakes one can commit while solving questions based on the distance formula. If the point P, 2, -1, is equidistant from the points Q, A, 7 and R, -3, A, then what will be the value of A from the following options? To solve this question by the distance formula, pause the video and then match your answer. From the question, we get to know that point P is equidistant from the points Q and R. Let's make an imaginary picture of it, which somewhat looks like this. Can you tell how can you find the value of A from PQ and PR? Correct. We will use the distance formula for this. The points P and Q in the distance formula, and by keeping the values of points P and R, we get a value of A is equal to 7. That is, option 2 is the correct answer. If you have selected option 1, then it's a good try, but this is the wrong answer. If you use the distance formula, then in place of the square root of the square of x2 minus x1 plus the square of y2 minus y1, we put the square root of x2 minus x1 plus y2 minus y1. Because of which, you get a statement without a variable, which is impossible. If you have selected option 3, then it is also a good try. But this is also the wrong answer. Because in place of square root of the square of x2 minus x1 plus the square of y2 minus y1, we put the square root of the square of x2 minus y2 plus x1 minus y1, and on the same basis, you solve it further. Because of which, you get the wrong answer. Hence, we hope that you must have understood why in this example, option 2 is the correct answer and the rest are wrong.